IP's addressing scheme, these four numbers separated by a dot, are visible to computer users. For example, we could SSH to that particular number, 155.98.111.50. If we do that, then we end up logged into the CADE machine lab1eng.utah.edu, and that name, lab1, is what we usually use instead of numbers. So we would often like to use names like that, which are easier to remember and type, and also so that the actual machine that goes with a particular name can be changed out. And so that's why we would normally SSH with the name. So this name has to be mapped to this number somehow. You notice that the naming convention also uses dots, and in this case there are 4 pieces to the name, each with a dot. However, these pieces really have nothing to do with these individual pieces. It's just a coincidence that lab11eng Utah has 4 pieces in its name, but all IP addresses will have 4 numbers. Now, the way that those names get mapped to numbers, if it's not by taking apart the pieces like that, is by using the DNS protocol. So instead of having every machine have a database of all possible names mapped to all possible numbers, DNS uses the network to go find the mapping as you need it. So for example, if this machine here wants to talk to lab1engineering.utah.edu, it's going to use DNS to get a mapping for that if it doesn't already have it locally, which is likely. To do that, it needs to know a DNS server, and it needs to know the numeric address for the DNS server. So that's how we get started. You need a small number of network addresses, 2 or 3 usually, that tell you who to ask. So this machine asks this other machine, which is at 8888, and that machine is one that either knows or can find out by asking still more servers that address matches, that name maps to this particular address. So that information can be sent back to this computer, and then it can contact the one that it turns out it wanted over there on the top left. The name mapping is not one-to-one. Multiple names can map to the same address. For example, if you point your browser at www.eng.utah.edu, it turns out it's going to go to the same thing as if you point your browser to cade.eng.utah.edu. Those end up talking to the same machine. You may notice that you don't see the same web content when you use those names, even though they go to the same machine. We'll talk about that next time, how that manages. Also, this host info program that I'm showing here, we're going to implement that. Now, not only can multiple names map to the same address, a single name can map to multiple addresses. So if you look up twitter.com, it turns out that's mapped to 4 different places right now. And the use of this is that different clients will pick various of those addresses to kind of spread out the work among different machines.